Hi ladies and gentlemen, this is Mr. Green and this is another in my series in geometry, and I'm going to be talking today about a very familiar topic to you. You remember this one from algebra, I'm sure. We're going to be talking about slope. And when we talk about slope, one of the things we talk about is the rise divided by the run. In geometry, that's the way we're going to refer to slope, is the rise divided by the run. Okay? So what I'm looking at here is what is the rise from J to K? Well, here's J here, and here's K here. And it looks like, okay, it's right over here. But if you look at it, it goes from here, goes up one, two, it looks like it goes up 3 full units. Okay? Now I'm not going to try to do all of these for you, but I do want to show you that some of them and make certain we're talking about how the rise is different between different points. Okay? From Q to M, it goes from Q and it goes up 1, 2, 3, 4, 5, 6 units. From P to L, it goes up 0 units. That's important to know. And R to S, it goes up from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we found all of them there, so we might as well write them all down. We got 6, we got 0, and we got 10. Okay? So let's look at the run now. So if we're looking at the run from J to K, J starts right here. We go to K, we're going over 1, we're going over 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we went over 9 units there. How about Q to M? Well, Q to M I see as being 1, 2, 3, 4, 5, 6, and it looks like we moved in a negative direction there, so it was a -6. P to L looks like it moved 1, 2, 3, and R to S looks like it moved, oh, it didn't run any, so we got a 0 there. So let's put these together. Rise divided by run. So we've got J to K goes 3 up and 3 over. And so my slope for J to K is going to be 3 divided by 9. 3 up and 9 over. Okay? Q to M, it goes up 6 and over -6. So it goes 6 divided by -6. P to L, it goes up 0 and over 3. So that would be 0 divided by 3. That's very legitimate. That's a 0. And R to S, we go up 10 and over 0. So that's 10 divided by 0. Wow, 10 divided by 0. Whoops. That's going to be an undefined slope, right? Because we can't divide by 0. So what I'm hoping you see here by inductive reasoning, I've been showing you examples, haven't I? That slope right there is called undefined. This slope right here is 0 going left to right. Okay? J to K, this slope here, that's a positive slope. It went up 3 over 6. Q to M, it's going down, isn't it? That's a -1. 6 over 6. 6 over -6 gives you a -1 slope. So what we're looking at are the 4 possibilities for slope being. It could either be undefined, pointer, undefined, 0, positive, or negative. Those are the 4 ways that slope could look at. Now, I was actually taking the values and counting them. Another way of doing this is to take their points and actually subtract them. Will it give you the same thing? Yeah, if we're looking at rise, going from S to Q, it goes up 1, 2, 3, 4. Well, that's exactly the same thing as taking the Y value, this Y2 right here, this Y2 right here, and subtracting Y1 from it. Well, the X values, moving from Q to S, it's going to take this X value, X2, minus X1. It's going to go 1, 2, 3. Works exactly the same way. It's just a formula for figuring it out. Which is easier to use, counting the points or figuring out the numbers? Well, you know what? It won't make a bit of difference. You could do it either way, okay? If you know the points, sometimes it's easier to use the formula. If you don't know the points, sometimes it's easy. If you know where the points are and you've got it on a graph, sometimes it's easier to count. I want you to do it whichever way seems easiest for you. Now, what they're giving you here is some information about some polygons. And we're going to try to play with some of these polygons. First of all, we got point A, which is at 5, 8. So they want me to try to take point A here and put it at negative 5, which is right here, 8, which is way up here. See if I can get this at negative 5 eighths. Negative 5, 8. Looks like I might have got it. Okay. They want me to put point B at 3, 4. So 3, move this there, 3 up 4, right there. They want me to put point C at 6, 1. Well, there's 6 and up 1. I can get it there. Yay. And then we're going to put point D at negative 2, 5. So we're going to go up to 5. Ta-da. Now, one of the things they want me to do is to show you that when we're plotting polygons like this and we're looking at the slope, see these two lines here? They're sloped exactly the same, aren't they? And if I put them right here on AD and on BC, the slopes were the same. That must mean that they are parallel lines. And if I take these two lines, which were identically the same, see, they're the same slope, and put them on AB and on DC, they're identically the same. Their slope is the same. What we just did by looking at the lines being the same to begin with and putting them down on these points, we're trying to show you, with inductive reasoning again, the fact that the opposite sides on this quadrilateral are parallel to each other. That means their slopes are the same. If they have the same slope, they're parallel to each other. That's what I'm trying to get across to you. Same slope, parallel. How will that help us? Well, if we know that two lines are parallel, or two opposite sides are parallel, then we know that we could get a parallelogram, right? If we got two pairs of opposite sides. So we must know that ABCD is a parallelogram. And we know some things about parallelograms that we've talked about earlier. So, two slopes, same, they're parallel. Okay? So, in this problem, they're wanting me to come up with another point on the line parallel to QS. They want a line parallel to QS that points through point A. Well, first thing I'm going to do is I'm going to count the slope out in this particular situation. So my rise is going to be from S to Q there, and S is at 2. So 10 minus 2 gives me a rise of 8. And it's got a run of, let's see here, Q is at 5 and S is at 1. 5 minus 1 is a 4. So I've got an 8 over 4. That means it rises, it rises 2 for every unit. So what I could do is I could go over here to my point A and count out a slope. It goes up 2 and over 1, right there. Up 2 and over 1. Up 2 over 1. Up 2 over 1. Now is that going to make a line that's parallel to this one? Let's see here. If I start right here with a line and draw through A like that, I think I've got a line that's parallel to QS. and we could pick any of those points that I just put on there as a point that would have been on that line. For example, this point right here, 6, comma 5, would have been one of the points that would have been on the line that's parallel to QS. Okay? Let's try that again, only with perpendicular. Perpendicular means it makes a 90-degree angle. So what we have to do is we count that same slope out, and we count it out as a rise of 8 over 4. Well, that actually reduces down, like I said, to 2 over 1, or 2. Now what I have to do to find the perpendicular slope is I have to turn this over. Okay? I'm going to put this one on top. I'm going to put this one on bottom. And it's going to wind up being a 1/2. One more thing I have to do to it, I have to put a negative sign on top of it. So that's going to be my slope of the perpendicular line. Why does it have to be this slope? Because when I multiply this times the 2 over 1, I'm going to get a product of -1. You multiply the two slopes together and you get -1. This is called a negative reciprocal. This little thing right here is called a negative reciprocal, when you flip it over and put a negative sign on top of it. So now that I've got a negative reciprocal, I can go from B, and I want to go down 1 and over 2. Okay? That's where another point that would be on that line. And if you don't believe me, let's draw that line. And I'm just going to use those 2 points, nothing more. I'm going to start right here, go through B, and have it come right over here, keeping it through B, through QS. I think that looks like a perpendicular line. As a matter of fact, I know that it is because I've calculated the slopes. And since the slopes product is -1, they're perpendicular to each other. Okay, using the midpoint formula, given any 2 points, we can find the midpoint between them. Simply add the x's together and divide by 2, and their y's together and divide by 2. So in this particular case, we've got an M point that is located at 1, 2, and our N is located at 5, 10. So all we've got to do is add those together. 5 plus 1 is 6, divided by 2 is a 3. 2 plus 10 is 12, divided by 2 is a 6. That means my midpoint is going to be at 3, 6. Right up here at 6. 3, 6. That's where my midpoint would be. That would be halfway between M and N. Okay? So, they're wanting us to find some midpoints here, and I'm going to save this one for a class connect, and we can do some of that to find some midpoints of problems and work some midpoint problems. But I think you guys are getting the idea. We found slope, we used midpoint, we were using those type of concepts. Those are using numeric and geometric patterns and ratios, and we're looking at relationships in polygons and circles and formulating testing concepts based upon the polygons and their component parts. So we're doing the things that we need to be doing as according to the TEKS, and we're making our progress through this course. Hopefully you're seeing how it relates to some of your algebra stuff that you were doing and some of the things that you did in previous year's work. Okay? Remember, I'm available in Toga on Monday through Thursday. I'm also in Class Connects on Thursday, so make certain you're here and getting all the instruction you can get. Otherwise, I'll look for you next time I see you.